So what we're going to do now is we're going to talk about something known as safe publication. And I'll explain to you what safe publication means in the context of Java objects, which is really what matters here because we're talking about Java. So we've been having some examples where certain objects have to be shared amongst multiple threads. Just as a simple example, the MemoAyah that we created is capable of being used across multiple threads. In fact, that's its whole purpose, right? You can have a pool of threads, and you're doing things like, computing whether something's a prime number, and you can have multiple threads in the pool checking simultaneously to see whether or not those numbers are prime. And so the MemoAyah is shared. So one thing you need to do if you want to share objects correctly across threads is make sure they're constructed properly. So you have to make sure that the construction will be up to code, no pun intended. So here's an example of an object that's not constructed properly with respect to sharing among multiple threads. And it's a very, very, very subtle problem. So what's happening here, and I'll look through this, I'll show you this code in a bit more detail in a second, is that in this code, this reference for the object for which this constructor is being called, this is a constructor, escapes because the object is not constructed properly with respect to concurrency. So here's the problem. What we're doing is we have a class called thisEscape, which gives you a hint that it's going to be this escaping. And in the class, we're going to take in a parameter called eventSource, and we're going to go ahead and register some event listener with the event source. So we're going to make a new event listener, which is going to have some method that does something when an event occurs. And the problem here is that we actually haven't finished constructing this object, and yet this listener is now open for business, even though we haven't really finished completing the construction of this object, because notice how this thing is occurring in the context of the constructor. So what's happening is this reference to this instance is escaping because there's a dependency, a hidden reference to the enclosing object within this inner class instance. Super duper subtle, super duper difficult to figure out, even to understand what the problem is. If you read this article, it'll explain in more detail what the problem is. So one problem is that this reference is escaping, so it's accessible before the object has been finished creating. And the second thing we have to do is make sure that objects are published safely. So what the heck does that mean? What safe publication means is that all the values in an object must be written out in such a way so that any objects in other threads will have all the object's state when they go to read the elements of that object. So this is very similar in many ways to the atomicity stuff we had talked about before. Remember we talked about atomicity properties with visibility, atomicity, ordering, and all this kind of good stuff. This is very much the same thing, except now we're thinking more at the object level as opposed to the atomic operation level. And in particular, this is very, very subtle and very weird. Storing an object reference into a public field, as you can see we will do here in a second, is not sufficient to publish that object safely with respect to multiple threads. So here's our little class A. We have a method called initialize, which is going to create a new array list, which is just a public field. And you'll notice we some thread creates a new instance A and initializes it. And then another thread, which let's assume for sake of argument gets access to this A somehow, it's going to go ahead and access mlist in object A. And it's not guaranteed, this is such a weird thing, it's not guaranteed that mlist in this thread will actually be published by this thread before this thread goes to reference it. And again, the easiest way to think about this is to remember that in a multi-core system with multiple processors, or rather multiple cores that are running in separate caches, when this thing gets assigned in one thread, because, as you'll see, there's no way in this particular code to push it out or publish it to other threads, it could very well be the case that this other thread doesn't get access to what it's trying to get by the time it goes to reference it. It might, but it might not. There's no guarantees. OK, so that's kind of the background. Now let's talk about, oops. So that's the end of that particular discussion.